All right, so get ready because today we're diving into something truly massive. Black holes. I know you guys have been asking for this deep dive. And we're going to unpack some really cool research and theories, try to really get to the heart of what makes these things tick, and hopefully we'll all have some aha moments along the way. But did you know that time actually slows down near a black hole? Like it literally slows down.
It does, and it really bends your mind when you think about it.
We'll explain how that works. I think that's going to be a good one.
What's so fascinating about black holes is that they really push the boundaries of what we understand about physics. I mean, we're talking about places where gravity is so strong that it warps both time and space, and not even light can escape.
Yeah, and that's kind of a hard thing to wrap our heads around, right? Like, where do we even begin with something that intense?
I think the best place to start is actually with something we experience every day,
Right.
gravity. So think about a ball falling to the ground.
Mhm.
It's Earth's gravity pulling it down, right?
Right.
Now imagine if we could take the Earth and just compress it, make it denser and denser, but keep its size the same.
Okay.
What do you think would happen to the gravity?
Well, if it's getting denser, I would imagine that the gravity would get stronger.
Exactly. And as the mass increases, the gravity intensifies.
Yeah.
Eventually, the gravity will become so strong that the escape velocity, or the speed you need to reach to break free from the Earth's pull, would actually exceed the speed of light.
Whoa, hold on. So not even light could escape.
That's right. And that is actually the defining characteristic of a black hole, a region of space-time where gravity is so powerful that nothing, not even light, can escape.
Okay, I'm starting to see why they call it a black hole then. But how does something like that actually become a black hole? It's not like planets just suddenly decide to become super dense, is it?
Well, no. Black holes were actually born from the death throes of massive stars, much larger than our own sun. When these stars run out of fuel, they can no longer support themselves against their own gravity.
Oh, so they kind of collapse in on themselves.
Exactly. Imagine a star millions of times larger than our sun, imploding and squeezing all of its matter into an incredibly tiny point. And we call this point a singularity. And it's where our current understanding of physics kind of breaks down.
So at the singularity, like, the rules of the universe don't really apply. Like, what happens to the stuff that gets pulled in?
Well, anything that crosses a certain boundary, called the event horizon, is destined to meet its fate at that singularity. So imagine it like a point of no return. Once you cross it, there's no coming back. As for what happens at the singularity itself, well, that's one of the biggest mysteries in astrophysics.
It's kind of like the ultimate cosmic shredder. Like, everything gets compressed into this infinitely dense point. But what happens to the information about what went in? Is it destroyed? Is it transformed?
That's a really good question. And it's a question that has puzzled physicists for decades. It's called the information paradox. And it touches on some of the most fundamental laws of physics. But before we get too deep into that, maybe we should talk about something that happens on the way to the singularity.
Okay, like during this like one-way trip.
Right. And this is where Einstein's theory of relativity really comes into play. See, time itself actually flows differently, depending on the strength of the gravitational field.
Wait, so time slows down near a black hole. Does that mean if I was watching someone fall into one, it would look like they were moving in slow motion?
That's exactly what you'd see. As they get closer and closer to the event horizon, you would see them slow down, and eventually they would appear to freeze in time. This phenomenon is called time dilation.
So for them, time would feel normal. But to someone watching from outside, it's like they're stuck in a time warp. That's incredible. But what about space itself? Does the black hole warp space too?
Absolutely. In fact, a spinning black hole actually drags the fabric of space-time along with it.
So it's like space-time is swirling around with the black hole?
It is. And this swirling creates a region called the ergosphere, which is outside the event horizon.
Okay, so we have the event horizon, which is the point of no return. And now we have this ergosphere, so what happens in the ergosphere?
Basically, nothing can stay still in the ergosphere. It's like imagine being on this cosmic merry-go-round that you can't get off of. Even light itself is forced to move in the direction of the black hole's spin.
So it's not just about things falling in, but also this crazy space-time whirlpool around it.
It really is. Black holes are incredibly dynamic objects. And it's important to remember that they aren't just cosmic vacuum cleaners sucking up everything in sight. They actually play a crucial role in the universe, even in galaxy formation.
Oh, really? I thought they were just like destroyers.
Well, they do have a reputation for destruction, but they're also creators in a way. In fact, supermassive black holes, which are millions or even billions of times the mass of our sun, are thought to reside at the center of most galaxies, including our own Milky Way.
Whoa. So there's a giant black hole at the center of our galaxy. How do those supermassive ones form? Do they just keep sucking things in and getting bigger?
It's not quite that simple. We're still unraveling the mysteries of how supermassive black holes form and evolve. But we do know they play a key role in the formation and evolution of galaxies.
So they're like the anchors of galaxies, like shaping them over time. That's amazing. But how can we even study them if they're invisible? I mean, how do we even know they exist if we can't see them directly?
That's a great question. While we can't see black holes themselves, we can observe their effects on the matter around them. It's kind of like looking for clues at a crime scene.
So what kind of clues do they leave behind?
One of the most dramatic clues is what we call an accretion disk. So as gas and dust get pulled towards a black hole, they form a swirling disk of matter, spiraling inward like water circling a drain.
Oh, I can picture that. And as this matter spirals in, it gets heated up, right?
Exactly. It gets superheated and emits intense radiation, sometimes outshining entire galaxies. And this radiation is something we can detect here on Earth.
So it's like the black hole is invisible, but the matter falling into it creates this cosmic beacon that gives away its location.
That's a great way to put it. We also have another tool that's revolutionizing our understanding of black holes, and that's gravitational waves. Remember those ripples in space-time we talked about?
Yeah, like the pebble in the pond analogy, you said they're caused by massive objects like black holes colliding. But how do we detect those waves?
It's incredibly difficult.
Mhm.
But we have these observatories like LIGO, the Laser Interferometer Gravitational Wave Observatory, and it can detect these incredibly faint ripples in space-time.
So we can actually hear black holes colliding. That's mind-blowing. What kind of information can we get from these cosmic sounds?
We can learn a lot, actually. We
Yeah.
can determine the masses of the black holes involved, their spins, how far away they are. It's like having this new sense to explore the universe with.
Okay, so I'm starting to realize just how much we've learned about black holes, even though we can't see them directly. But I'm guessing there's still a lot we don't know, right?
Absolutely. In fact, some of the most fascinating aspects of black hole research
Mm.
delve into the realm of speculation and what-ifs. For example, could black holes be gateways to other parts of the universe? Or even other universes entirely?
Okay, that's where those wormholes come in, right? Like the cosmic shortcuts. I can't wait to hear more about that.
Yeah, we'll definitely dive into that and other mind-bending possibilities in our next segment.
Sounds like things are about to get really interesting. Buckle up, folks. Welcome back. So last time we were exploring some pretty intense concepts, things like time dilation and the information paradox.
Yeah, we really got into the nitty-gritty of what happens when you get too close to a black hole. It's not a place you want to visit.
Definitely not on my vacation list. But you also hinted at something really intriguing, the idea that black holes could be more than just these cosmic destroyers.
Yeah, that's right. They might even hold the key to understanding some of the biggest mysteries in the universe,
Mm.
like the origin of our universe itself and the nature of dark energy.
Okay, now you've got my attention. Let's start with those wormholes. Could black holes actually be portals to other parts of the universe? Or even to other universes entirely?
It's a mind-blowing concept, isn't it? The idea that you could step into a black hole and pop out somewhere else in the cosmos, or maybe even in a completely different universe.
It sounds like science fiction. But you said that Einstein's theory of relativity allows for the possibility of wormholes.
That's right, but there's a catch. Creating and maintaining a stable wormhole would require something called exotic matter, which has negative energy density.
Negative energy density. Okay, that sounds pretty exotic. Have we ever observed anything like that?
Not yet. It's purely theoretical at this point. But that doesn't mean we should dismiss the idea altogether. Sometimes theoretical physics can point us in directions we never would have imagined.
So even if the science isn't there yet, the idea of wormholes is still a tantalizing one. It really stretches our imagination. Makes you wonder what else might be out there.
Exactly. And that's part of what makes black holes so captivating. They force us to confront the limits of our understanding and to consider possibilities that seem impossible.
Speaking of seemingly impossible possibilities, you mentioned something about black holes being connected to the origin of our universe. That one really caught my attention.
Yeah, it's called the black hole cosmology theory. And it proposes that our universe might have been born inside a black hole.
So our entire universe is inside a black hole. Whoa!
That's a lot to process. How does that even work?
Well, imagine the singularity at the heart of a black hole. Instead of being the end of everything, it could have been the starting point for a new universe.
So in this theory, the Big Bang, the event that we believe started our universe, was actually the result of a black hole collapsing in some other universe.
That's the basic idea. It's a way of trying to understand the initial conditions of the Big Bang. It's still very much a hypothesis,
Hmm.
and there's no direct evidence to support it. But it's a fascinating concept to explore. It definitely challenges our conventional view of the universe.
Okay, you mentioned another big mystery, dark energy. How are black holes connected to that?
Well, we know that dark energy is this mysterious force that's causing the accelerated expansion of the universe.
Hmm.
But what exactly it is, we don't really know.
Right, and you said that black holes could be the source of this dark energy. But wouldn't their intense gravity pull things together, not push them apart?
Yeah, that's the paradox, isn't it? But some physicists have proposed that the energy associated with the event horizon of black holes could somehow be contributing to the overall energy density of the universe, and that this could be driving the accelerated expansion. It's a very complex idea, and still very speculative.
So the very edge of a black hole,
Hmm.
the point of no return, could be pushing the universe outwards. It sounds like something out of a science fiction novel.
It's a mind-bending idea for sure, and it shows how much we still don't know about black holes and their role in the universe. But even if we don't have all the answers yet, the fact that we can even ask these questions, that we can speculate about these incredible possibilities, is pretty amazing.
It is, and it's a testament to the power of human curiosity and scientific exploration.
So where do we go from here? What are the next big questions that scientists are trying to answer about black holes? Are we getting any closer to actually seeing one directly?
Well, we've already taken a huge step in that direction with the Event Horizon Telescope, which captured the first ever image of a black hole shadow back in 2019.
Right, that was a landmark achievement. But I understand that wasn't the end of the story. There's more to come from the EHT, right?
Absolutely. The Event Horizon Telescope is constantly being upgraded and refined, and scientists are hoping to use it to study the dynamics of black holes in even greater detail.
So what could we see with these upgrades? What are the scientists hoping to capture?
Imagine being able to see those accretion disks in action, swirling around the black hole, or maybe even catching a glimpse of those powerful jets of energy shooting out from the poles.
That would be incredible. It would be like watching a cosmic fireworks show, but with much higher stakes.
Exactly. And by studying these dynamic processes, we can learn more about the feeding habits of black holes, how they grow,
Hmm.
and how they interact with their surroundings.
And maybe even test some of our most fundamental theories about gravity and space-time, right?
That's right. The EHT is like a giant cosmic laboratory, allowing us to test Einstein's theory of general relativity in the most extreme environments imaginable.
So it's not just about pretty pictures, but about really pushing the boundaries of our understanding of the universe.
It's about both, because sometimes those pretty pictures can reveal something truly profound about the nature of reality.
Well, I'm definitely hooked. But before we get too carried away with future possibilities, I think it's time to address one of the biggest elephants in the room, the question of what happens inside a black hole.
Ah, yes, the ultimate mystery. What happens to the matter that falls into a black hole? Does it get crushed out of existence at the singularity? Is information lost forever? These are some of the most fundamental questions in physics, and we're still searching for answers.
And those answers might just revolutionize our understanding of the universe as we know it. Sounds like a perfect topic for our final segment. Let's dive into the heart of the unknown.
All right, welcome back to the final part of our deep dive into black holes.
The final frontier.
We've covered so much ground, from the basics of gravity to the mind-bending possibilities of wormholes, and you know that black hole cosmology. But now we're about to confront, I think, the ultimate mystery, what happens inside a black hole.
This is where things get really interesting and a little bit spooky. Because we know that matter collapses into a singularity at the heart of a black hole. But what does that really mean?
Right, like,
What are the properties of a singularity? Does it mark the end of space and time as we know it? It's almost like the singularity is like this cosmic trapdoor, where the laws of physics as we understand them just cease to exist. It's terrifying and fascinating at the same time.
it really is. It's a place where our current theories break down, and we need new physics to describe what's happening. Some physicists believe that the singularity might not even be a point of infinite density, like we often imagine it, but rather it could be something else entirely, something we haven't even conceived of yet.
So it's not just a matter of like our instruments not being powerful enough to see what's happening. It's that our understanding of the universe might be fundamentally incomplete when it
Exactly.
comes to black holes.
Precisely. And this is where the information paradox comes in. The idea that information that falls into a black hole might be lost forever, which violates some of the most fundamental laws of physics.
Right, because according to quantum mechanics, information cannot be destroyed. So where does all that information go when it enters a black hole?
That's the million-dollar question. Physicists have been grappling with this problem for decades, and there are many different theories out there. Some believe that the information is somehow encoded on the event horizon, the boundary of the black hole, while others suggest that it might be radiated away through Hawking radiation, a theoretical process predicted by Stephen Hawking.
Right, Hawking radiation, that's the idea that black holes aren't completely black after all, that they can actually emit particles and energy over incredibly long timescales.
That's right.
But if black holes do evaporate, what happens to all the information they've consumed? Does it reemerge somehow? Or is it lost forever?
It's a mystery.
It's like the ultimate cosmic mystery novel, with clues scattered throughout the universe. But the ending is still unwritten.
And the best part is, we're actively writing that ending right now. You know, scientists around the world are conducting groundbreaking research, pushing the boundaries of our knowledge, developing new theories to try and solve these mysteries.
It's exciting to think that we're living in a time where we're making such incredible discoveries about black holes, and that there's still so much more to learn.
Absolutely. And the study of black holes is not just about understanding these enigmatic objects themselves. It's about probing the deepest secrets of the universe and challenging our very notions of reality.
So as we wrap up this deep dive,
Yeah.
what's the one thing you'd want our listener to walk away with?
I hope they've gained a sense of wonder and awe at the incredible power and mystery of black holes, and that they're inspired to continue exploring and learning about these fascinating objects.
I think black holes are a perfect reminder that there's still so much we don't know about the universe, and that's what makes it so exciting to study. So keep looking up, keep asking questions, and never stop exploring the cosmos.
Well said.
That's all for this deep dive into black holes. We'll see you next time for another journey into the heart of a fascinating topic. Until then, keep those aha moments coming.